So I hope you have been surprised by the output which you saw in the computer. So let's understand the logic, real logic behind it. So first of all, I will go with the example of 260. After that, I will go for 132. So let's go and see for 160. So first of all, we have to convert 260 into binary. Since it is integer, so it will take 4 bytes. 1, 2, 3, 4. Okay. 260. So the binary conversion, you can use the conversion section 260 divided by 222, and you will get the binary version of it. Now let's see what happens. This is the exact binary conversion. You can convert it on your behalf. This is the binary value of 260, 256 plus 4, that is 256 plus 4 is equal to 260. Now here will be 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Now what happens when we convert an integer that is the size of 32 bit into a size of 8 bit? As I have already shown you, this is our integer and this is our byte. And as in the previous example, I have shown you by pouring this data into this, and you saw that some of the data got filled. After that, the whole data got spilled on the plate. So the same concept will be the same concept holds here in the Java. What will happen? So you see here the size of byte is 8 bits and the size of integer is 32 bits. Now what happens when we convert int value, that is int value to byte? What will happen? Java trims the remaining 24 bits. It holds, since the size of byte is only 8 bits, so while converting from int to byte, these 24 bits, these 24 0, 0, this are trimmed. It will contain the least significant bits. These bits, the only remaining 8 bits which are least significant, not the most significant. So this Java retains this value. Okay. Java retains this value. So what is going to be in the byte b variable? What is going to be in this byte b variable? Only these 8 bits. None of this. This one will not go there. Only this 8 bits. Okay. So we will have 0, 0, 0, 0, 0, 1, 0, 0. Now here I have shown you. You can see plus minus 2's complement. Okay, means sign 2's complement. So as I have told you that byte in Java is of size 8 bits and it is always in 2's complement. Signed bit with 2's complement. It is always retaining 2's complement. So this number is always in 2's complement. So let me tell you about the sign concept here, which is very necessary to understand you. I will clear this board and let me write it about here. The output for 260 which we get in the binary was 0, 0, 0, 0, 0, 1, 0, 0. Here you can see this value is not 1. This value is not 1. Here you can see this value is not 1. So it is a positive number. Okay. So in the console we will not have this positive, but it will be considered as a positive number, and after that we will calculate the magnitude of it. So what will be the magnitude? Okay, the magnitude is the value the decimal value of this decimal version of this. So if we convert this binary number to a decimal number, then we will have the value as 4. Okay, so the output on the console will be, this is the most significant bit. The most significant bit, the value, the bit which has the maximum value here is 0. So 0 stands, as I had already told you, 0 stands for positive numbers, and 1, that is the most significant bit, is if 1, then it is a negative number. So when we are going to have output in Eclipse console, we will have an output of 4. Means plus 4 it should be, but plus is not already not shown on the console, so it is only 4. Okay, but in case of negative, we will have the sign, this sign, if this value here this bit is 1. Okay, so you got it. When we run and convert this into 62 byte, it will have output of 4. Okay, so I think you got the concept of why the output in the computer was and the console was 4.